here are your study guide solutions. You should try it first. I'm going to help you. I'm going to make sure you did it right. But you should always try these first. If I want to simplify the square root of 18, I need to know what perfect square goes into 18 evenly. So you can't write down 3 times 6 because those aren't perfect squares. So 9 is a perfect square. So 9 goes in 18 twice. The square root of 9 is 3, and then what's left over is 2. So same thing here. What perfect square? And we write it as 4 times 3, the square root of 4, and what's left behind. Now for cube root, we need to know our perfect cubes. So what number goes into 16 evenly that I know the cube root of, the perfect cube? That's 8. And the cube root of 8 is 2. And what's left over is the cube root of 2. 81, that's 27 times 3. The cube root of 27 is 3, and then the cube root of 3 is left over. Sometimes we have algebra involved. When you have algebra, you divide the exponent by 2. So the square root of 64 is 8, and then divide by 2 the exponent, and you just have 8x. For 48, we have two numbers that are perfect squares that go into it evenly. We need the larger of the two numbers, which is 16. And then the square root of 16 is 4. X to the 4th square root, divide the exponent by 2. And then what's prime, what's left over that I can't square root is 3. 40, we're going to write as 4 times 10. And then I have x squared. Now, if you have an odd number, you pick the largest even number smaller than it. So instead of 5, the largest even number less than 5 is 4. We need one more y, so it adds up to 5. But now we can simplify it. So the square root of 4 is 2. The square root of x squared is just x. The square root of y to the 4th, divide by 2. And what's left over is 10 and y. Again, we're going to simplify this. 16 is a perfect square. 6 is an even number. Y to the 7, we're going to write as y to the 6 times y. So then the square root of 16, divide by 2, divide by 2, and what's left over under the square root sign is just y. Here, the cube root of negative 8 is negative 2, and then we divide by 3, so that's x squared. So you divide by the index. 54 is 27 times 2. X to the 5th, we need to write it as a multiple of 3. So I'm going to use 3 and 2. The cube root of 27, what number 3 times itself is 27. X cubed divide by 3, that's 1x, and then what's left underneath is 2x squared. The cube root of 27, that's a perfect cube. X to the 4th is x cubed times x. So we write it in a friendly way so I can simplify it. The cube root of 27 is 3. Divide the exponent by the index, that's 1x. Divide again, that's 1y. And then what's left that you can't simplify is just x in the middle. 72 is 8 times 9. And then the rest I can simplify because they're multiples of 3. So the cube root of 8 is 2. Divide the exponent by 3, that's x. Divide by 3, and then what's left behind is 9. Adding and subtracting. So the first rule to adding and subtracting radicals is to simplify it first, and then only like radicals can you add or subtract together. So 8, I'm going to write as 4 times 2. 18 is 9 times 2. So the square root of 4, that's negative 2 root 2. The square root of 9, that's 3 root 2. And then if the radicals match, you add or subtract the numbers in front. They're called the coefficients. So negative 2 and negative 3 together is negative 5. And you have your answer. Square root of 28, that's 4 times 7. Square root of 63, that's 9 times 7. So the square root of 4 is 2, the square root of 9 is 3, and then they're like radicals, so the numbers that are in front, negative 2 and negative 3, that's negative 5 root 7. Here again I want to subtract. Now root 2 can't be simplified, but 8 is 4 times 2. The square root of 4. And then what we have is negative 1. I know you don't see the number in front, but it's negative 1 and negative 2. That's negative 3 root 2. 4 root 3 can't be simplified, but 12 is 4 times 3. So the square root of 4, root 3 left, they're like radicals. 4 take away 2, and you have your answer. We have negative 2 and the cube root of 8. Well, the cube root of 8 is 2. And the cube root of 64 is 4. So this is negative 4, take away 4. There's no radicals left because they're perfect cubes. Here, the square root of 64 and the square root of 121, and then negative 8, and then 2 times 11, and then 22 take away 8. That is 14. All right, when we multiply, we would want to simplify first if you can, but you can't. They have to be the same index. So they both need to be square roots, which they are, and then you multiply the insides together. So that's 60. 60 is 4 times 15. So the square root of 4, and then 15 is left over. Same thing here. We multiply them together. The square root of 36 is 6. So the answer is negative 30. Sometimes we have to distribute. So root 3 and root 6 is root 18. Now, these are unlike numbers, so they just go beside each other. So it's not 15. It's 5 times root 3. They just go beside each other. Root 18 is 9 times 2. And the square root of 9. So that's 3 root 2. And that's 5 root 3. Anyways, these are not like radicals. So these radicals are different numbers, so you can't add them together. They have to match exactly. All right, this is 2 times 6, root 12, root 4. So this is 4 times 3. This is 2. So you end up with 2 root 3 plus 2. The next one, we're going to draw a box. We don't really need to draw a box because it's a difference of squares, but we're still going to do it for fun. So 3 plus root 5, 3 take away root 5. Multiply for each one. 3 times 3. 3 times root 5, not 15. Not 15. And then root 5 times root 5. Now, these cross out. They match. One's positive, one's negative. You end up with 9 subtract, and the square root of 25 is 5. So you end up with the answer 4. So again, we have root 3 and 4, root 3 minus 4. We're going to multiply it out and then combine. Remember, not 12. This is not 12. So the square root of 9 is 3. These cross out. Minus 16, and you have your answer. Oh, excuse me. 25. So we have 3 and root 5 and 4 and root 5. So 4 times 3. Again, you can press pause and try it first, and you'll learn it. Unlike numbers, not 20, not 15. They go beside each other. And then 5 times 5 is root 25. So 3 plus 4. First of all, this is 12. And the square root of 25 is 5. So I add like numbers. So 12 plus 5 is 17. This is 7. And you have your answer. These can't be combined together. 26. A lot of roots here, but we'll get through it together. So I'm going to multiply this together. This is 4 and the square root of 25. We'll simplify that soon enough. That's square root of 10. This is the square root of 10. And this is the square root of 4. So you can multiply like radicals. So the square root of 25 is 5. So that's 4 times 5. This is negative 8 plus 1. That's negative 7. And the square root of 4 is 2. So I have 20. Take away 4. So that's 16. And you have your answer. All right, second page. Now we're dividing. So 50 divided by 25, that's the square root of 2. 20 divided by 5, that's the square root of 4. The square root of 4 is 2, and 2 times 2 is 4. We're just simplifying. If you can't divide it, then we take the irrational number in the denominator and multiply top and bottom times it to get our answer. So that's going to give me root 10 over 5. Again, I can't divide, so we're going to multiply by root 3, top and bottom. So that gives me root 2 times root 3 is root 6. 5 root 3. Root 3 times root 3 is 3. That's it. This we have to use the conjugate. So 2 plus root 2, top and bottom. That gives me 4 and 2 root 2. On the bottom, it's really a difference of squares, so I just need to go the first number times the first number, that's 4. The last times the last, that's the square root of 4. So I end up with 4 plus 2 root 2. 4 take away 2. And then I could divide everything by 2 as well. And have our answer. Here, we're going to go root 5 subtract root 3. And again, I'm going to multiply it out. So I end up with 5 subtract root 5. Root 5 times root 5 is root 25. That's it, right? Root 3 times root 3 is 3. That's a property that you should know. And then 5 take away 3 is 2. So again, the conjugate, 5 plus root 3, top and bottom. Now the top I'm going to have to FOIL. So 3 and negative root 5, 5 and positive root 3, and multiply it out. Not 25, not 15. This is the square root negative of root 15. So the numerator, if I combine like terms, there are no like terms there, is there? So I'm going to go 15, negative 5 root 5, plus 3 root 3, minus root 15. None of them are like. I can't add any of them together. The bottom is 5 times 5, and root 3 times root 3, which is 3. So if I put it together, I can't combine any of this together. That's 22. All right, last one there. Again, 3 plus root 2 is called the conjugate. Again, for the top one, I need a box. So I'm going to FOIL that out, that top one. That's negative 4 in root 5, 3 in root 2. I'm going to multiply it out. So 3 times negative 4. Again, you should try it first and then watch the video. Press pause. So when you multiply it out, reckon now root 10 and root 5, that is root 10. So the top, again, there's no like terms. So I'm just going to go negative 12. Order doesn't matter. Negative 4 root 2 plus 3 root 5 plus root 10. The denominator, 3 times 3, and root 2 times root 2. So if I put this all together, I have negative 12, negative 4 root 2, plus 3 root 5, plus root 10 over 7. All right, turn the page. That was the toughest spot. It gets better. Just write it as a radical. So the denominator is the index and the numerator is the power. That's it. So again, the denominator is the index, that's square root, and then that's all to the power of 5. That's how you write it in radical form. If you have a radical, then we have a base and we have a fraction. The index is your denominator and your power is your numerator. So again, we have a base, the index is the denominator, and the power is the numerator. If I want to simplify this, write it as a radical. That's the square root of 4 to the power of 3. So the square root of 4 is 2, and then 2 to the power of 3 is 2 times 2 times 2. So this answer is 8. Same thing here. This means the cube root of 27 to the power of 2. So the cube root of 27, what number 3 times itself is 27, to the power of 2, and the answer is 9. All right, solving equations. We need to make sure an extraneous solution is when you are left with a negative number under a square root or a square root is equal to a negative number. Now, when I only have one square root equaling another square root, we remove the square roots and just solve what we see. So I'm going to add x to both sides, and I'm going to divide by 4, and then I got to be careful. If I plug 1 in for x, does that give me a positive number under the square root sign? Yes. Plug in 1 for x. 4, take away 1. Does it give me a positive value under the square root sign? So that's a good answer. Here again, a square root equaling a square root. Remove the square roots and solve what you see. So I'm going to subtract n. I'm also going to add 8. And divide by 2. I can see we're going to be in trouble here. N is equal to negative 13. If I plug in negative 13 for n, that gives me a negative number under a square root sign. It can't equal that. There is no solution here. In fact, there's no real solution if not anything else. So that's called an extraneous solution. It's restricted. That's because that answer makes what's under the square root sign negative. All right, try the next one. In this one, we want to isolate the square root. We only have one of them. So just get the square root by itself. Add 2. That's 4. And then to undo a square root, we square both sides. So when I square both sides, that's 16. And when I square, the square root and the square cross out. Subtract 1, and then divide. And then 15 divided by 3. And you have your answer. Oh yeah, we need to check, right? So if I plug 5 in for x, 3 times 5 plus 1, is that a positive value under the square root? Yes. All right, we have the square root isolated, so we're going to square both sides right away to undo it so they cross out. Then I'm going to add 3. Divide, it does go in evenly. That answer is 4. And if I plug 4 in, that gives me a positive value equaling a positive number, so it works. What number am I? 45. A couple more equations, some graphs, we got this. All right, I want to solve this equation, so I'm going to square both sides. Now, that leaves me with x squared, and then the square and the square root cross out. I have a quadratic equation, so I need to make this equal to 0. So to make it equal to 0, I'm going to add x to both sides. I'm also going to subtract 56. We have no like terms, so they just go beside each other. So at this step, we have a trinomial. So we're going to factor it with this diamond. And go, what two numbers multiply to negative 56 and add to 1? So that's 8 and negative 7. Those are not my solutions. So when I solve it, and I take x plus 8, what makes the first one 0? And what makes the second one 0? So negative 8 and positive 7. Factors and solutions are opposite numbers. And then look. if I look at the original equation, I have to cross out the -8 because the square root of a number could never equal a negative answer. So that answer is extraneous. So the only answer that it can be is 7. That works, which it does. Okay, same thing here. We're going to square both sides. So when I square both sides, you have x squared, and the square and square root cross out. We're going to make it equal to 0. I'm going to subtract 14x. I'm going to add 45. And then draw a diamond to factor this. So two numbers that multiply to 45 and add to -14. So that's -9 and -5. We can also do it this way. We can take each factor equal to 0 and solve it. So take x minus 9 equal to 0, x minus 5 equal to 0, add 9. One solution is 9, add 5. Another solution is 5. And then make sure this gives positive value. So positive 9, 14 times 9 is bigger than -45. It's a positive number. It works. 14 times 5 is also bigger than -45. It also works with a positive value. So no extraneous solutions. Both answers work. Number 47. To solve this, the square root is isolated. We're going to square both sides. But we have a binomial that we're squaring. So we got to be careful. When I square it, this one I have to FOIL. So x and -5, we need to multiply it out. And then we write it all in. So combining like terms, that's x squared minus 20x plus 25. These just cross out, and you have 22 minus 6x. Then I'm going to combine like terms. So the power term is here. It's positive. So I'm going to add 6x to both sides. So -20 plus 6 is -14. I'm going to subtract 22 to both sides. That makes this 0. 25, take away 22. That's 3. What did I do wrong? Because this does not solve. So I'm thinking, because this is an irrational answer. So before I start doing something fun, like completing the square, I want to make sure that I did not make a mistake. I made a mistake. Didn't take long to think that out. This is -5 and -5. Together they make -10. Gee willikers. And then -10 plus 6 is -4. It was all me. So this should say x squared minus 4x plus 3. That works. So when I have a diamond, the two numbers are -1 and -3. And you can take each factor equal to 0 and solve it. So we're going to add 1. We're going to add 3. And make sure both answers are good answers. So if I plug 1 in, it's a bad answer. And the reason is this. Look at the left side. What's 1 take away 5? That leads to a negative answer. That's -4. Can the square root of a number be negative? No. This is a bad answer. What happens with 3? Well, guess what with 3? If I go 3 take away 5, what happens there? Again, a negative answer. Guess what? Both of them are bad. You can't square root a number and it equals negative. Both are bad. This has no solution. Both are extraneous. So you could have one solution, two solutions. You could have no solutions. All right, let's try this one more time. 48, last one. So we're going to square. So when I square both sides, I got to FOIL this. That's x plus 2 and x plus 2. Multiply it out. So this, the square root and the square cross out. And then I have x squared. We have 4x and 4. Then we're going to combine like terms. So we're going to subtract 2x. I'm going to subtract 39. I hope I did this right. So I subtracted 2x. Where I get, 4. That's 2. I gotta get this right. Then 4 take away, I'm doubting myself, but I know it's going to work out. All right, 4 take away 30 and negative 35. It is going to work out. So the two numbers that multiply to negative 35 and add to 2 are 7 and negative 5. Make each equal to 0 and solve it. So each factor equal to 0. Solve it. So one answer when you subtract 7, the other answer when you add 5. So right away, this is a bad solution because negative 7 plus 2 is a negative value. The square root of a number can't equal a negative number. But 5 does work. 5 plus 2 is 7. This is the square root of 49. 5 is a good solution. Negative 7 is extraneous. And you did it. All right, that's working at solving equations. Last part, can you graph? So first we're going to graph the square root. So we're going to write down what a equals, that's 1, what h equals, that's negative 6, and what k equals, negative 2. Make sure that h is the opposite number. Then the points. So for a square root, the 3 points are 0, 0, 1, 1, and 4, 2. And then we're going to change them. So to the x coordinate, we're going to subtract 6. So to every x I subtracted, so 1 take away 6, 4 take away 6. To the y coordinates, we're going to multiply times 1 and then take away 2. So again, we're going to go 1 times 1, take away 2. 2 times 1, take away 2. And then these points are going to go on my graph. So negative 6, negative 2, negative 5, negative 1, negative 2 and 0. And then draw my curve. What's the domain? That comes from your original point, the x value, negative 6, to infinity. The range, that's your first point, the y value. That's the lowest y value, which is negative 2. And the end behavior, even though it doesn't say it. The right end goes up, and the left end is the point hk, which is negative 6 and negative 2. All right, try number 50. Can you graph it? Start here. What does A equal? What does H equal? What does K equal? Be careful you did the opposite number. The 3 points we're going to start with, which are 0, 0, 1, 1, and 4, 2. All right, so I'm going to add 2 to every x coordinate. So I want 0 plus 2, 1 plus 2, 4 plus 2. To the y coordinates, I'm going to multiply and then subtract. So 0 times 2, and then subtract 4. 1 times 2, which is 2, take away 4. And then 2 times 2, take away 4. And then those are the points that are going to go in my graph. And then draw it. So the domain, again, is the first x value, which is 2. The range is the first y value, which is negative 4. And then the end behavior. So again, the right end goes up, and the left end is a point, which is at 2 and negative 4. All right, 51, we're going to graph it. You should try it first. So these are the points I'm going to change. So I'm going to add 3 to every x. That's where those numbers come from. I'm adding 3. And then I'm going to multiply times 3 and add 1. So 0 times 3 is 0. Add 1. So you can put that on your graph. 1 times 3 is 3. Add 1 is 4. And then 2 times 3 is 6. Plus 1 is 7. And then draw your curve. The domain is the first x value, which is 3. The range is your first y value there, which is 1. And then the end behavior. The right end goes up, and the left end is a point, hk, which is 3 and 1. All right, one more. You should really try it first before watching the video. You're doing this so you can pass the exam. That's worth more than finishing the packet by a lot. So A is 2, H is -1, K is -5. We write down the 3 points, 0, 0, 1, 1, 4, 2, and change each one. So we're going to subtract 1 to every x, and then we're going to multiply and subtract 5. So 1 times 2, subtract 5. 2 times 2 is 4, subtract 5. And those are the points that go on. So -1, -5, 0, -3, and then 3, -1. The domain is the first x value, that's -1 to infinity. The range is the first y value, that's -5. And then the end behavior. So the right end goes up, and the left is hk. So it goes to the point -1 and -5. All right, that's the square root. All right, here's the end of your review packet. Can you graph a cube root? So it starts the same way. A, if you don't see a number in front, it's 1. The 3 is the index, so it's not a transformation. H, the opposite number, which is 1, and then K is -3. For a cube root, the numbers start with 0, 0, 1, 1, but we need a -1, -1. That makes a cube root different, is you can cube root a negative number. And then we're going to change it. So the H changes the x's, add 1 to every x. To the y, we multiply and then subtract 3. So 1 times 1, take away 3. -1 times 1 is -1, take away 3. And then put that on our graph. Now, if you did it right, they are going to line up. We start with that middle point, and we curve up to the right, go back to that middle point, and curve to the left like a S. The domain and the range never change, all real numbers. And the end behavior, the right end is going up, and the left end is going down. So it doesn't go to a point. So the right end is up, and the left end is down. 2 more. I think you should try it. Press pause. A is 3. H is -4, the opposite number, and K is -1. The 3 points we're going to start with are 0, 0, 1, 1, and -1, -1. We're going to subtract 4 to every x. To the y coordinate, we're going to multiply times 3 and then subtract 1. So 1 times 3, take away 1. -1 times 3 is -3, take away 1. And then these will line up. So -4, -1, -3 and 2, and -5 and -4. And then they curve up to the right, and they curve down to the left, just like that, using those points. Again, the domain and range don't change. The end behavior. So the end behavior is going to be consistent. Unless there's a reflection, like on this last one where A is negative, it'll flip. But the right end goes up and the left end goes down. All right, last one. All right, let's try it. Press pause, do our best. Let's see, did you do it right on your own? A is -3. H is the opposite number, -3. K is +3. The 3 points are 0, 0, 1, 1, -1, -1. Did you change these points correctly? So subtract 3. 1, take away 3. -1, take away 3. To change the y, we multiply and then add. So 0 times -3 is 0. add 3, that goes on my graph. 1 times negative 3 plus 3 is 0, that goes on my graph. Negative 1 times negative 3 is positive 3 plus 3, 6, that goes on my graph. And notice how this goes down to the right and up to the left. So the domain and range don't change, but the end behavior, now the right end goes down and the left end goes up. That's it. Mr. G Math over and out. I hope that helped. I hope you actually tried to learn the packet and not copy the video and doing your best. You can always do the questions over again on a blank piece of paper and really practice them now that we went through it once, to really try to do your best when you take your exam. I believe in you. Thank you for finishing your study guide, and I hope you do really well in the exam.